Let's take a look at this review problem considering the motion of a spring, and the question is what kind of force is necessary in order for the spring to experience resonance. To do this, we first set up the governing differential equation mu double prime plus gamma u prime plus k times u equals the force F naught cosine omega t. So this one has an external force, so I have something other than 0 on the right-hand side. We have three constants that we have to solve for, m, gamma, and k. Gamma is 0 because it's frictionless, so that's easy. To determine k, we use the fact that the spring stretches 4 inches when 10 pounds is attached. So we use that F is equal to k times x, so the force of 10 pounds equals k times a third of a foot. And so k is going to be equal to 30 pounds per foot. Last, we need to figure out the mass m. And so for that, we'll use force equals mass times acceleration. The mass, again, is 10 pounds of the object attached to the spring. Mass times acceleration due to gravity is approximately 32 feet per second squared. And so that means that the mass is equal to 5/16 pounds per foot per second squared. And I believe that is in slugs in imperial units. So plugging back over here, we get that 5/16 mu double prime plus 0 plus 30 times u equals F naught cosine omega t. Let's simplify this a little bit. So multiplying by 16, we get 5u double prime plus 480u is equal to 16 F naught cosine omega t. And we can also divide by 5. We get u double prime plus 96u is equal to 16/5 F naught cosine omega t. Okay, so let's find the roots of the characteristic equation. So the characteristic equation will be r squared plus 96 equals 0. And so the roots will be plus or minus I times the square root of 96, or plus or minus 4 times I square root of 6. Okay, so that basically allows us to answer the question. So there's the root, and so if omega is equal to 4 square root of 6, then this resonance occurs. The reason that happens is because if that's the differential equation, then u of t would be equal to, the solution from the homogeneous equation, c1 cosine 4 square root of 6 times t plus c2 times sine 4 to square root of 6 times t. Then I also have to add on the particular solution to match the right-hand side. And in this case, that would be a times cosine 4 times square root of 6 times t plus b times sine 4 square root of 6 times t. Now if I stop writing like this, this is exactly the same thing as the top line except with different constants. So to prevent that from happening, I throw on the extra t's here according to my rules for the method of undetermined coefficients. And so as t gets large, this part blows up, and so the system experiences resonance. The last part of the question involves what are the units of omega. The units of omega are going to be over seconds because we have to have t is in seconds, and so this needs to be in over seconds so that the thing in parentheses has no units, and I can take the cosine of it. So the units will be 4 square root of 6 times over seconds. Alternatively, we could write this as 4 times square root of 6 hertz, cycles per second. And so that would be the units of omega.